So we are going to discuss this bobbin problem. Okay, so we are given a bobbin of mass 3 kg, this plate. So actually the bobbin looks like this. Bobbin is used by tailors. I think they put the thread is wrapped around this cylinder, and this bobbin rotates when fit in the sewing machine, and the thread comes out. Okay, so this is the real bobbin. This is the side view, and on this cylinder, like there is this inner cylinder is like this, and the thread is wrapped around this. Okay, like this thread is like, so on one of the thread this mass is there, 4.5 kg. Okay, so this is the problem, and it is put on an inclined plane which had an angle theta. This is an equilibrium, both translational and rotational, so it is still like this. In reality, in normal cases is not possible, but we have made some arrangement. Because of this it is actually uh, in equilibrium position. So now we have to find the this angle. Simple, we have to first apply rotational equilibrium, that is we have to balance the torque. So we have to uh, we are going to find torque about this axis passing through the center of inner cylinder and parallel to, like this, है ना? Okay, so which forces are going to provide the torque? So there are, first we have to draw some forces. So first is the normal force from the ground. This normal force, I have drawn one normal, but actually there are two normal, one on this plate and another on this plate. So actually what happened that the torque of this normal and this normal will cancel out each other, so the net torque of normal will be 0. Okay, so then this force comes, then there is the force of weight of this bobbin, but that passes through the axis of, passes through axis, so the distance is 0. So the torque is 0, because torque is equals to r vector cross f vector. So here r is equals to 0 because it is passing from the same axis, this weight. So the torque of this weight is 0. Now this block of 4 point, this is also an equilibrium, so the tension has to be equal to its weight. So tension is equals to 45 Newton. Now this is one more force, 45 Newton, which is acting on this, that is going to provide a torque. Okay, what is the distance of this line of action of force of this from the axis? This is, and this is equal to 5. Okay, so just imagine that this was the cylinder, and here it was like this. Okay, like here, so the distance of this from the center is 5. So this is one force. Would there be another force? It has to be there, because otherwise how can it be in equilibrium? So there is yet another force. That force is, I think there is static equilibrium, friction. Okay, where friction is sufficient to prevent sliding. Okay, so friction is also there. So now we can see that this is the line of action of force for this tension, like this, and the uh, r position and the distance is like this. Okay, so this is the r vector and this is the f vector. So we know torque is equals to r cross f, so we come from here to here. Now if you know that the direction, it is going to be into the page. Okay, if you come from r to f, this is anti-clockwise, so we need another torque which is clockwise in nature. So to provide clockwise in nature, now friction has to act in this direction, because if suppose friction is acting here and its distance from the center is like this, so now you do if r cross f, so it comes out to be in clockwise direction, so these two will cancel out each other. Then only it is possible that it is in rotational equilibrium. Okay, because if friction acts downwards and this is r, so again this is also anti-clockwise, so this will not cancel out each other. So two forces which are going to provide torque are for friction and this tension. So we have calculated the value of tension, that is 45 into 5, that is the distance from the axis, and F into 6. This is the axis. Okay, this is the axis. And so the friction value comes out to be this. From here we are going to make two equations along the axis and perpendicular to the axis. So perpendicular to the axis is normal force is equals to 3g cos theta. This 3g is the weight of the bobbin and its component 3g is component perpendicular. So this is theta, this is 90 minus theta. If I am going to extend this, this is also theta, so this is also theta, so this is also theta. These are corresponding angles. Okay, this one and this one, so this is also theta. So this component perpendicular to this is 3g cos theta plus 45 cos theta. The component of tension along this, the tension is acting like downwards, so its component in this direction. Similarly for along the plane, the friction is acting upwards, so friction must be equal to the component of weight in this direction plus the component of tension in this direction. Okay, so 3g sin theta plus 45 sin theta. From here we get normal is equals to 75 sin theta and friction is equals to 75. Now you know the value of friction, we have calculated it already here. So from here we get the value of sin theta is equals to 1 by 2 and theta is equals to 30 degree. That's the solution of the problem. So the main thing in this is this diagram. So if you are really able to visualize this, and another thing that why the torque of normal is zero, it's not because it's passing through the line, it's not passing through the line, but the but if we consider, even if we want to consider the torque of this, so it will cancel out by this one. Okay, this normal will cancel out each other's torque.